So what if we had our 100 random cards? Let's forget the packs of 15 and let's just say we're buying them one at a time. What do you think the mathematical formula is going to be for how long that you should expect to take?
So maybe we've got sort of the same thing. We have 1 plus 101 over 100. Plus 102 over 100. Plus 103 over 100. ... Until we've gone through all of the cards. And then would be
What's your last term going to be here?
199 over 100. We need 100 terms here.
Right. How did the numbers work for the dice?
So we had 6/6 plus 6/5. Oh, okay.
The probability here is like it's more than 1 every time.
Well, this is the expected number of rolls, and it was increasing.
Yeah.
But it didn't increase in this way.
Okay, what was our next term?
6/4.
The top number should always stay constant.
And one thing you can see is on the last term, when there's only one slot open, how many should that take you on average?
Should take you the number of whatever you have.
Okay, so let's go back and see if we can repeat this with 100.
So then we start with 1, or
Okay.
100 over 100.
Alright, 100 over 100.
And then 100 over 99.
100 over 99. Okay.
And plus 100 over 98.
Okay, 100 over 98.
Then
And what's it going to go all the way down to at the end?
100 over 1.
100 over 1. Yeah.
Alright.
Good. So we can factor out the 100. And I'm just going to reverse how it's written. This is going to be 1 plus a half plus third
Fourth.
plus all that to 1 over 100. That's how long it should take on average. So initially it seems like a very difficult problem, right?
Yeah.
Then just add up all the fractions, the unit fractions from 1 to 100.
Yeah. And as we get a little bit, as we study a little bit more math, we're going to learn that this sum looks a lot like something called the natural logarithm of n. So the natural logarithm tells you how many powers of e does it take to get up to 100. Now e is between 2 and 3, right? 2.71.
Yeah.
Okay, so 3 to the 4th is 81,
So
right?
Yeah.
So the logarithm of 100 should be a little bit more than 4. Maybe it's 5.
between 4 and 5.
Can put it in on our calculator here. There's a logarithm button, ln right there. That's 4.6. And you can see if I do 2.71828 raised to the 4.6,
You get
99.5 basically.
get very close to 100. And if I do 4.6e to that power, I get
very close.
So 100 times 4.6 is 460,
Yeah.
right? So it should take me roughly, if there's 100 of them, I might have to buy 460 on average to find all 100. Pretty crazy, huh?
Yeah.
Well, it turns out we can answer this coupon collector problem.
Nice.
Yeah. All right, cool. Good job, guys.